So in this recording, we're going to continue to look at conditional probability, especially the concept of given that. In other words, that's going to limit us to a subset of the data. Okay, so this notation right here, in this question, this bar, this vertical bar, is read given that. All right, meaning you're only considering the people over 6 feet tall. So what it says is, just kind of using your intuition, which of one of these is larger? We don't have any numbers to go on here. Okay, this would be read the probability that a player plays in the NBA given that that person is over 6 feet tall. And this one would be read the probability that a person is over 6 feet tall given that that person plays in the NBA. Now let's just think about that. Let's just start with this first one. You know lots of people that are 6 feet tall. So you always start with the given that part. So just rattle off. I bet you can name 10 or 15 people you know personally that are over 6 feet tall. I am one of them. I do not play in the NBA, right? I bet you don't know that many people personally that play in the NBA. So this is a relatively small number out of your total friends and acquaintances that are over 6 feet tall. Kind of small over here, right? Let's look at the second one. Okay. This is given that a person plays in the NBA. If you've ever watched an NBA game, think about all the people you know that play in the NBA that you've seen. You don't know them personally, but you've seen them on TV. How many of them are over 6 feet tall? And I would guess it was most of them. They might look short on TV, but they're probably 6 foot or greater. Okay, most of the players in the NBA. So this is a large probability. Okay, so to summarize, okay, the second one would be a larger probability than the first one. Almost all the NBA players are tall, so a higher proportion of the NBA players would be over 6 feet tall. On the other hand, there are many adults that are over 6 feet tall. Relatively few play in the NBA. Next question. Okay, we're looking at the probability that, this is kind of like a taco problem, the probability that the fans at the Bulls game get a free Big Mac, and the other category is, did they win or lose? Okay, so the first question we're going to look at, what's the probability that they won given that they got a free Big Mac? So we'd write it this way, P1 given that Big Mac. Okay. So this one, we're going to start with the given that part. So you start with the Big Mac part. We're only including right in here. Don't allow yourself to look at any other part of the table than this right here, the Big Mac row. So within that row, what's the probability that they won? Well, it's just 15 out of 16. Okay, so 15/16. If we were to convert that into a decimal, we're looking at 0.938. So it's pretty likely that if they get a Big Mac, meaning they scored a high amount of points, that they're going to get that win. All right. So now on the other hand, what's the probability that they got a free Big Mac given that they won? So it'd be P Big Mac. And what you'll find is these aren't necessarily the same given that they won. So we're only this time going to allow ourselves to look in the win column. So I'm just considering right here the win column. Okay, don't look at any other numbers. So given that they won, what's the probability that they got a Big Mac? So that's 15 out of 36. Not quite as high a probability, okay? They sometimes win but don't score enough points to get that Big Mac for the fans. Okay, so that worked out to be 0.417. And the final question of this set, we're going to look at the probability of a home run hitter for the Blue Jays, okay, Jose Bautista, and what relationship that has with the team winning or losing. Okay, so why don't you pause, work out questions A, B, C, D, and then play the recording when you want to get some feedback. Okay, so for this one, it's an and scenario. The ands are the easiest ones to do. You just simply identify that one spot. So a win and a home run right here. 17, and it's out of the total 81. So 17 out of 81 is our ratio. And that one works out to be 0.210. Okay? Next one. This is an OR scenario, so slightly more complicated. Let's figure this out together. For the OR, okay, remember we consider, I'm going to go about it the way I think is easier. Okay, we're going to consider the wins. All our wins are right here. 46. All right. And then home run. So where were the times when he got a home run that we haven't considered yet? So that would be right here. So it's the 46 plus the 8. Okay, 46 plus 8 works out to be 54. All over the total, which is 81. Okay, so 54, 81, 667. Next. Okay, the next two have to do with given that. So the given that I find to be pretty straightforward as well. You just have to start with the right place. So given that they lost the game, we always start with the given that. Start here and just get in on the lost the game part. So that's right in here. Lost the game, we're only considering this row. So what's the probability that they saw a home run? Within that row only. So that would be 8 out of 35. Okay? And 8/35 works out to be, if I'm not mistaken, 0.229. Okay, our last scenario, just going to erase that other one. Let's get a black pen for this one. All right, last scenario. Given that they won the game, we're going to start with that. Start with the given that. What's the probability that they didn't see a home run? Okay, so we're given that they won the game. We're only within here. What's the probability that there was no home run? So it'll be 29 out of 46. And we'll convert that into a relevant decimal. 29 over 46. That's going to work out to be approximately 0.630. Thanks for watching.